Hey guys, welcome back to my channel. Happy Sunday, everyone. So this video I'm going to talk about what is a SYN-Flood attack, all right, in cybersecurity, particularly in offensive security, as well as I will also help you in this video to understand how we can prevent against these attacks, okay, particularly for your home network, all right. So if you are using an enterprise network, there would be network level intrusion detection system that will catch hold of these SYN-Flood attacks, and also the firewall, the next gen firewall, which you call the perimeter firewall, would definitely catch hold of these SYN-Flood requests and block at the source level. All right, and however, for your home network, these shall not be enabled by default. Hence, you would want to enable this feature of preventing your home network from these attacks. These attacks can cause, I think, particularly SYN-Flood attack can cause a DOS attack, which is nothing but denial of service. All right, so let me talk about this in detail of what exactly this attack is and how it works, etc. And the step that we can take to prevent our home network or home router, basically. All right, so let's quickly get started, guys. So basically, this attack, a SYN-Flood attack, is nothing but it is a type of denial of service attack on a computer server that happens mostly on a computer server. Also, your router can also get compromised due to this attack. All right. So this exploit is also known as a half-open attack. All right, and SYN-Floods, in a shorter way, are one of the several common vulnerabilities that take advantage of TCP/IP model to overwhelm target systems, guys. All right, and this attack uses a process known as TCP three-way handshake. All right, and as part of this handshake, the client and server exchange messages to establish a communication channel, basically. All right, and this attack involves having a client repeatedly send synchronization requests, which stands for SYN stands for synchronization packets. All right, and to every port on a server using a fake IP address. Fake IP address means it would be the attacker's IP address, which will be masked according to me, and then that will be called as a fake IP address. Okay, and when the attack begins, right, the target server sees the equivalent number of attempts, okay, to establish communications. I mean, what do you say? So basically, when an attack happens, the target server sees equivalent number of attempts to establish a communication. All right. So basically, what happens is it sends a SYN acknowledge request or synchronization acknowledged packet from all of the open ports in response to each communication attempt that is made. Okay, and also an RST packet, or it's also known as reset packet, that comes from all of the closed ports. All right, so basically, for you to understand it better, I would want to show a picture here, okay, that explains three-way handshake, a normal three-way handshake versus a compromised handshake, all right, which is also known as half-open connection. Okay, basically the second diagram on the right side describes how the SYN-Flood attack happens. All right, so on the left side, this is the normal three-way handshake. Basically, a client, a server communicates. A server could be anything, an on-prem server, or it could be a web server, web application server as well. So what will happen is client, as in the user's computer, as in my case it will be my computer, and a server could be anything, a Facebook server, or any server in the form of on-prem server in case of an organization. Okay, it could be anything, a file server, a SQL server, or it could be an exchange server could be anything. All right, and the client starts sending a synchronization request first to the server. Okay, as soon as it sees that the client is a genuine source, okay, and immediately what it does is it sends another response. Okay, so basically this is like a meet and greet session, guys. Okay, and then the server sends back a response to the client with a synchronization acknowledged request. Okay, and the packets are exchanged in this three-way handshakes. Okay, and after the client receives the response from the server, it again sends back a response to the server that I have successfully received your message in the form of a packet, okay, network packet or data packet. Okay, and this is how it happens, guys. If any of this process gets compromised, then it results in maybe you can call it a man in the middle attack, or you can also call it as a SYN-Flood attack. Okay, so particularly we're not talking about the man in the middle attack here, we are talking about the SYN ACK request. All right, so what happens in the SYN-Flood request is the client. Okay, so what happens is the client's MAC address gets spoofed, okay, by the attacker, and then the attacker uses a randomized IP address. Okay, and then what the attacker does is it tries to send a request, spoofing the MAC address of the actual client. Okay, and then the attacker's PC or the IP address becomes a hostile client. Okay, and then he starts sending requests to the server. Okay, so basically the intention is to damage the server, guys. Okay, and and also what the attacker's intention could be to damage the server in the very first place, or maybe crashing the server. Okay, the attacker is not going to get any benefit out of this, but it's just the what do you call it, like inner sense of peace, okay, the attacker may get, okay, by damaging or crashing the server by sending tons of synchronization requests. Okay, and server may assume that the request is coming from the proper source, since it would not have the idea of randomized IP, or it would not have any sort of information of the hostile client here. Okay, basically it would not have the information that the client, the actual source client, has got compromised and its MAC address got spoofed. As a result, the traffic is coming from a bogus source. Okay, that information server would not be happening, and hence what would happen is, like I said, once these three steps happen, okay, um, I mean, a normal three-way handshake should have all these three steps successfully completed for a connection to get closed successfully. All right. But however, in case of a SYN-Flood attack, okay, the hostile client does not return an acknowledge request over here. If you see here in a normal three-way handshake, the client, the normal client, I mean the genuine client would send an acknowledgement request back to the server. However, in case of a SYN-Flood attack, or the half-open connection, you can call the hostile client, okay, where it spoofed the MAC address of the actual or genuine client, I mean, okay, is not sending the final acknowledgement request back to the server. All right. Hence, what would happen is, instead, what this hostile client is going to do is repeatedly going to send the synchronization requests to all the server ports available within this server, within the target server. Okay, and then the hostile client, as in the attacker, knows that a port is open. Okay, when the server responds back with the SYN-ACK packet. Okay, means that by that time, what attacker would come to know is there is no protection against a DOS attack. So basically, when the hostile client tries to send the synchronization request, and if the server is responding back with a SYN-ACK request back, okay, then obviously it means that there is no DOS attack prevention that is put in place on the server, meaning there is no firewall level protection, okay, that is available. So that is an indication that attacker will repeatedly send this SYN requests, okay, knowing that there is no protection against these DOS attacks or these SYN-Flood attacks, okay. And hence what happens is, as the hostile client, as in the attacker's PC, requests appear valid to the server. Basically, like I said before, all these SYN requests that the hostile client is sending back to the server, it appears genuine to the server, basically. Okay, since, like I said before, the attacker is going to use the fake IP addresses, as well as as a result, what happens is, because the attacker's identity is masked here, the server is unable to close the connection by sending the RST packet to the client. Basically, the connection gets closed after the server sends back an RST packet to the client computer. Okay, that is meaning reset packet. Okay. Okay, to close the connection, basically. Okay, first the connection is opened up by the client, and then the connection is closed back by the server. However, here the client is sending repeated open connections, and server is unable to close the connection because client is not sending the final acknowledgement request. Okay, as a result, what happens is server is unable to send the reset packet request to close off the connection. Okay, hence what happens is this goes on in a loop. Okay, repeatedly the client tries sending the SYN requests back to the server. Hence what happens is server is busy finding a way to close the connection for all those other requests. Okay, as a result, server is not able to recognize out of all these bogus requests which of them are genuine requests and which to actually respond. Okay, as a result, server remains busy at this point in time because of loads and tons of SYN requests being sent to the server. Okay, as a result, it also fails to respond to the actual genuine requests in this point in time. Okay, and like I said, this result ensures that the connection stays open, and before a timeout can occur, okay, another SYN request arrives from the hostile client. Okay, so basically this is why it is called as half open connection. Okay, and the server becomes so busy with the hostile client requests that communication with legitimate traffic, that is the traffic coming from a legitimate source, is difficult or almost impossible for the server to address. Okay, so basically, like I said, how this can happen, basically how this can happen is, like I said, one of the method is that is the MAC address spoofing, which an attacker can spoof the spoof a client computer's MAC address and try to send the traffic on behalf of that computer. Okay, or this can happen due to a botnet. Okay, that what happens is, this particular botnet, what I can say, it produces something called distributed denial of service attack. Okay, that spreads source of malicious packets over to many machines, and it appears all the sources in the form of botnets appear real to the server. As a result, this nature of attack makes it difficult to mitigate. So basically, DOS attacks could happen on a home network, guys, and on within an organization, mostly these type of attacks happen in the form of distributed denial of service, DDoS attacks. Okay, where botnets play a vital role in carrying out these attacks, and it's very difficult to mitigate these attacks. All right. And if you ask me how these can be mitigated, okay, so there are several techniques where we can mitigate this vulnerability also, we can say, in a fashion we can call this as a vulnerability also. Okay, and so one such technique is called as rate limiting. Okay, then limiting the number of SYN requests that can be sent to a server at any one time. Okay, this could be done, this could be inculcated within the firewall, perimeter firewall, like I said. And the second one, as usual, it is again related to firewall, is known as intrusion detection system. All right, so the firewall has something called intrusion detection system that would be able to detect and block these malicious traffic from a SYN-Flood attack. Okay, so most organizations these days have next gen firewall, right, that will have intrusion detection system in place, and this protection system will prevent against these attacks for the organizations. Okay, and then there is another technique called SYN cookies. Okay, so I have no much idea about this technique, but I think so basically this technique where each connection request gets a unique identifier ID. Okay, and then this approach can block illegitimate requests coming. I mean that may degrade the TCP connection. I mean that may degrade this three-way handshake. All right, and these are the techniques. The very first two methods that I told you, techniques I told you, rate limiting and intrusion detection system, is the common methods that is widely used and that I'm aware of. However, there are more techniques as well which I don't have knowledge about. So probably a network security expert can have more knowledge about this, because these are networking areas again where these things, I mean, in order to remediate this vulnerability, it needs a lot of networking configuration changes, okay, which require expertise of a level of a network security expert or a network engineer basically. All right, and then so in this video, what I actually wanted to show was, I wanted to show you how to prevent against these attacks, particularly coming in the form of SYN-Flood attack that would act against your router, basically that can compromise your home router, home networks router. Okay, and when it comes to, like, you may ask me, how do you think that this SYN-Flood attack is going to damage my home networks router? Basically, your home router's firmware is often rather very fragile, guys. Okay, simply throwing a lot of SYN packets to your router, okay, that too in a fast manner, okay, can cause a crash, okay, taking down the connection completely. So basically, sending tons of SYN packets that to your actual home router can significantly damage your router and even at times crash your router, and as a result dropping off your internet connection itself for a brief length of time or a long period of time. Okay, so it's important for you to implement a mitigation for this particular attack. Okay, so all you need to do is, if you are using a TP-Link's router, okay, in my case I'm using TP-Link Archer C5 router. Just going to quickly log into my router's console, or I can call it a panel. Here what I'm going to do is I'm just going to go to security, guys. Okay, and here I will have inbuilt firewall and DOS protection feature, guys. I'll just click this one here, and by default this is turned off, meaning it would not have this feature enabled by default. Hence what you need to do is you just need to enable it. And then basically you may ask me, how does an attacker, like how do an attacker will carry out this attack successfully? Like I said, in case of a distributed denial of service attack, they will use botnets, okay, that are programmed to do these attacks or carry out these attacks. In case if the attacker wants to carry out this attack on a single host, like in case for the attacker wants to attack your router, which is a single device, that should just work with a single denial of service attack. There is no need of carrying out a distributed denial of service, because the attacker is not attacking an organization itself, right? It's just a single device. So he can use tools like hping3, right? That's available in Kali Linux. It's one of the security testing tool which could be used in offensive way as well. So it's widely used by all security testers, security pen testers, as well as the bad actors in the form of attackers. Okay, they can use that tool to carry out these DOS attacks successfully on a server or any sort of networking device in the form of a router. Okay, so you may ask me, what is this hping3 tool, right? So basically it's a networking tool, guys, that is able to send custom ICMP ping packets, UDP packets, and TCP packets, and to display target replies, basically. All right, like ping, that does the ICMP response, right? Internet Control Messaging Protocol. So this tool handles fragmentation and arbitrary packet body size, and also it can also be used to transfer files, okay, under supported protocols. So basically, an attacker or a security tester can use this hping3 tool, apologies, to test firewall rules as well as to perform um, MAC address spoofing as well as port scanning, and then can also test network performance using different protocols, as well as do path in MTU discovery, okay, and also perform traceroute like actions under different protocols. And also this tool can be used to fingerprint a remote operating systems, take details about operating systems remotely, that is particularly on a remote host, okay, and also audit TCP/IP stack model, as well as like I said, this HPing3 tool can be used to script as well. Okay, this HPing3 tool can be used to script botnets as well. Okay, this tool is a very powerful tool, guys. So you can just do kind of googling and research yourself on how this tool works. So there should be a lot of videos made on this HPing3 tool. Okay, particularly that is by default available in Kali Linux operating system. Okay. And so, yeah, like I said, this SP3 tool is helpful in sending ICMP packets, UDP packets, as well as TCP packets. So we need protection against all these incoming packets, okay, in abundance that comes in abundance when the attacker carries out these SYN-Flood attacks. Okay, so we will just select the efficacy to high, all right, and we will just save this configuration. Okay, that's it. If you click on save, that's enabled, guys. You can see here the progress. Okay, and I think this is where the rate limiting as well comes in. Okay, so you can limit the packet size, okay, that is sent by the attacker. There is the synchronization packet size, right? The attacker can make this, okay, like in case the attacker has is actually sending, okay, 10,000 packets per second for a single synchronization request. So what we can do here is we can flag it as a high level. We can just mark it as a red flag, okay, and then here we can just say anything around 3,600 or anything above 5,000 packets, we should block it like that. So it's just like putting rules, all right? So 1 minute, guys, I'm getting a phone call. So guys, I'm back. So basically this feature is to customize our requirement, customize these settings to our own requirement. So here, my router currently thinks that any packet that is sent between 5 to 3,600 packets per second is to be considered at a high level, okay, that is severity level, I will say. So in my case, like if I think that 3,600 is not a problem for me at all, because my server has that much bandwidth to handle these many packets, all right, so what I can do is I can just change this to probably 5,000. Okay, if I think anything between 5,000, okay, anything beyond 5,000 is to be flagged as dangerous, then in that case this particular protection feature has to block it. All right, this is how you set it, guys. Okay, so let's see, let's do one thing here. We'll change the value, right? Just click on save. Okay, I think this is the max value that we can set. I think between 5 to 3,600 is what I think we can set. If we do this here, okay, it's not accepting, guys. Probably if I do a 3,000 here, okay, so I think this is the default value, guys. Anything between 5 to 3,600, that's all we can set, I think, in my router. Basically anything, like I think probably if the attacker is sending 5,000 packets, probably this feature may not work. Okay, probably anything between 5 to 3,600 packets per second, I think this protection feature would be able to handle. So again, it could be a limitation, I would say. So the max packet that it can handle is 3,600 packets per second. All right, that is for this the severity level high. Okay, the max packets this protection feature can handle is 3,600 alone. Anything between 5 to 3,600. So within this stipulated packets per second setting, we can change any value between 5 to 3,600 basically. All right, so that's all we can tweak here. So anything beyond that, I don't think this protection feature can handle. Okay, so for now, this is how you implement this feature, guys, within this security panel here. Okay, there is a DOS protection that you can enable. So this way you can protect your router from these SYN-Flood attacks coming from an attacker or a bad actor, basically. All right. And if you found this video helpful, please hit the support button, guys, and don't forget to subscribe my channel for more useful technical content like this with regards to cybersecurity. Okay, and we'll meet in the next video, guys. And let's stay safe. Cheers. Bye bye.